Hi, my name is Kat, and I love robots. I also love space, which is why I'm so excited to talk to you about NASA's new Mars rover, Perseverance. Mars is the fourth planet from the Sun. Out of all the planets in our solar system, Mars is most like Earth. In fact, several billion years ago, Mars was very similar to Earth, with a substantial atmosphere and even liquid water. Since life began deep in the Earth's oceans around the same time that there was water on Mars, scientists are looking for traces of ancient life. If there ever was life on Mars, then it would probably be in the form of microbes, really, really small organisms that you can't see without a microscope. The Perseverance rover, which just landed in February, is a robot that NASA sent to Mars to collect soil and rock samples and investigate signs of ancient Martian life. Now, although Mars is our planetary neighbor, it's still really, really far away. The Perseverance rover was launched July 30th, 2020, and it didn't land on Mars until February 18th, 2021. That's almost 7 months. That means if you took off from Mars on the first day of school, you wouldn't land until April. Because of this huge physical distance, it takes the signals we use to communicate with the rover a long time to travel too. Depending on the positions of Mars and Earth around the Sun, it can take between 5 and 20 minutes to send instructions to a rover on Mars, and double that time for the rover to send information back. This makes driving a rover pretty tricky. Imagine playing a video game where there was a 40-minute delay every time you pushed a button. That would take forever. Because of this delay, scientists and engineers have to send groups of predetermined instructions, or commands, to tell the robot how and where to go. This is called a program. Recently, Perseverance received its first instructions to move a few meters and take a picture of where it landed. You can see where the rover touched down and its tracks start. Today, you're going to program your own Mars rover, but first, let's talk about some of the obstacles a rover on Mars might face. First, the Martian landscape is littered with rocks. While rovers are designed to drive over most of these rocks, just like a car might drive over small obstacles on the road, some rocks might be sharp or jagged and risk damaging the rover. Other rocks, like boulders, might be too big for the rover to climb over. Like the Moon, Mars also has a lot of craters due to impacts of space debris. While some of these craters are small, others are very big and deep, so it's probably a good idea to avoid them if you can. Like Earth, Mars also has land formations like mountains, trenches, and cliffs that would be difficult for our rovers to navigate safely and efficiently. Finally, since Mars is covered in sandy dust, areas of soft sand can cause the rover's wheels to get stuck. This is called a sand trap and is really dangerous for a rover. In 2009, that's how the Spirit rover's mission ended, when it became stuck and unable to recharge its solar panels in the Martian winter. Now it's time for you to program your own Mars rover. For this activity, you're going to need 2 pieces of paper and something to draw with. Imagine you're programming a rover on Mars. First, you're going to need a map. So let's draw one. The rover starts at this corner of the paper, the landing spot, and needs to get to this corner, the sample site in a lake bed where scientists think there might be possible signs of microbes. Now that you know about some of the obstacles on Mars, I want you to make a map that the rover will have to navigate. This map should include at least 4 obstacles found on Mars, but you can include as many as you want. Don't be afraid to get creative. You can use some of the obstacles we already talked about, or you can research some more. Pause the video here while you make your map. Now that you're done drawing your map, you're going to have to help your rover navigate the obstacles. But just like a real Mars rover, you're going to have to give it all the instructions at once, in a program. On another piece of paper, explain to the rover step by step how it will get from start to finish and avoid all the obstacles. When you're done, you can draw or print a picture of a rover, cut it out, and act out your instructions. Is there anything you could do to improve what you're telling the rover? Or maybe you can make it go a little bit faster. Congratulations, future engineer! You used what you learned about NASA's latest Mars mission, the challenges of communicating with a rover on Mars, and the obstacles the Martian landscape presents to program your very own rover. Keep it up, and maybe one day you'll help future colonists explore Mars.